Hi, Michael. How are you?
Great, Aseem. How are you?
Yeah, I'm doing great. So, with me, I have a transports company CEO. His name is Michael Steele, and he's been doing phenomenal work with Steele to revolutionize the transport industry in terms of adding technology, the cutting edge technology. So, welcome, Michael.
Yes, super. Thanks, Aseem. Thanks for having me. This is great. Yeah, we're definitely trying to revolutionize the transportation industry. We're leveraging many different technologies and solutions to do that. We're working hard on it, and it's fantastic.
Sure. And I am Aseem Jain, and I am a speaker, and I am also a cloud architect. So today, what we are going to do is we will do some interactive conversation to learn the concept of serverless computing. So this is a buzzword these days: serverless. Few years back, the cloud computing was the same thing. Maybe like 7, 8, or 10 years ago, now people know cloud, but with that cloud, the new concept of serverless computing, which has come up these days. So we will be discussing that and how we are using it on our transport project as well. So quickly introducing myself, my name is Aseem Jain. I am author of Software Design Pattern book. I am engineer with Rackspace Technology. I am also a certified programmer and a NoSQL expert. I am active YouTuber with a million view on Tech Talks. I'm a cloud architect who love building serverless application, and I have passion for building these applications. So in this conversation, we are going to cover on high level few topics. We'll start with the use case of Costco, where their server was down and they lost 11 million in revenue during the Thanksgiving Day. When they wanted their server to perform best, it performed worst. And that's what we will build with our transport, that when we need it, it would work that same way. So we'll cover it later when we'll cover this use case. Then we'll understand about cloud server computing, about what a three-tier architecture is. Then we'll explore the concept of cloud computing, basically the benefits. After that, issues in operating servers and how to solve it with NoOps, which is again a new buzzword these days. And then how serverless works without is it, I mean, are there no servers? Things have changed so much, so we'll it would be interesting to learn that. And we will explore some serverless services by AWS, like their S3 DynamoDB database, their Lambda function, which is function as a service, API gateways, and at the last, most important, a quick demo of a microservice application of e-voting, so that people can vote even if they are at home. They don't have to go in corona covid to a crowded place, stand in a queue for hours. So something which we are trying to leverage the technology to empower democracy and allow people to exercise their fundamental right of voting. So, with that question, Michael, I believe you are a responsible citizen. Do you vote every time?
I vote every time. I've never missed an election.
Oh, wonderful. That's nice. So here comes the use case. Basically, what happened is during last Thanksgiving, um, Costco has some infrastructure in place. They have servers and then they do some stuff, but they were not expecting so much of traffic on a Thanksgiving. And I wanted to buy this Apple Watch from Costco. Actually, they had an offer, and I tried couple of days, at least 20 times each day, and with excitement and with the hope I'll be able to buy. But what I see is, boom, server is down. And I was forced to buy it from Best Buy and other places, and that's the story of so many people. I mean, that's fine, but can that be avoided? Because it costed a lot of money. And Rackspace basically helps the people and the companies so that they can architect their product in such a way so that it's on clouds, it's elastic, and when they need it the most, it performs basically whenever they want. And one example is one of our Costco, like one of our Rackspace customer. I mean, he wasn't the Rackspace customer. He went to Shark Tank, and then he was not expecting all of several thousand people will hit his website at the same time. They did. They are the investors basically, and their website crashed. The last thing they wanted. So that's how we'll explore more what the elasticity is. But before moving ahead, we have to understand what a client server architecture is. So right now, when we open a website, Amazon.com or any website, we write www and website name. That is what we can treat the web browser as a client. It could be your mobile phone, it could be your laptop, iPad, or any other machine or terminal. So long as soon as you send the request, that request is served by a machine which is called as a server. And in India, this happens a lot that in bank when people go, they need something and server is down. They want to book the flights or the railway tickets and the server is down. So that's the worst nightmare for everyone, and nobody knows actually why server is down, how server is down. So to understand that part, let's look at this thing which goes behind. So just imagine you have a car and your car is not working, and then you have an important meeting or a date to go, a coffee date, maybe some romantic date. So worst thing you want, the car breaking down, but then you start checking. You have to debug if the engine is fine, if the fuel is fine, if the carburetor is working as expected. And then there are several components, but even if one component, either the electrical system is down, coil is down, fuel system, anything is down, you cannot drive the car. So under the hood, you have to check several things. Michael, do you remember on the black convertible I had some issues, and then you and Stain were trying to debug that?
Oh, I remember debugging it for sure.
So same thing happens. We have things which are not working and we need it, but it needs a lot of effort to look up. Nowadays, the cars are coming with some panels. You just plug it in some sensor and it would basically tell you what's the car, what's the component of that part number, what's the error code. So it made very easy to debug the problem in the car. Otherwise, you will open up and check each and every system, may it be alternator or the battery or the coil or the electric system or the carburetor, etc. So underneath this client server, what is happening? You're opening this website and it goes to a three-tier architecture. So how it goes is, first your front end server would come, which would authenticate and validate if you are you. For example, I'm trying to order a laptop. So I made the payments and I am trying to buy it. So tier one's responsibility is to check if I'm not a hacker, I am what I am claim. I am that same person. After getting or grabbing that information, it sends the request to second tier, which is the application layer, which would do the processing, maybe my payments, maybe the availability of the laptop and the model number and all that. Once it does that, then it would update the data in the database that payment has been successful, laptop has been sold out. All these things will be some queries in the database, and everything is done, then I'll get the response. But imagine there is any fault in database, entire application won't work, and from the front side you will get the message server is down. Imagine there is some problem with the application layer, you will get the message server is down. In the front end, server is down. Between the network, because these things are connected with network, server is down. There is some hardware failure, so your entire website cannot work. To come to the analogy of a car, even a small thing is wrong. So you need to open up the entire car to to check what is wrong, where is wrong, why the engine is knocking, or whatever the problem is. You have to open up the engine. The problem with IT is this is Thanksgiving. People are trying, they are in mad rush to buy things, and that's not the appropriate time to open up the servers and websites and check, because it's a production system, it's running. So we can do that. That is why the ops plays an important role here. And then that's why the problem happens that company have to re-architect their system in such a way so that it's easy to debug, easy to find, or I would say not to have the overhead of such things wherein you have so many components and responsibility to keep the operation that one thing is down can take the entire system down. So with the advent in cloud computing, there are few positive things which have come up. So we'll discuss about that. In nutshell, Michael, what do you think cloud computing is?
Yeah. So what I see is cloud computing is really a cloud platform that offers a wide variety of services that businesses of all types, certainly development businesses in general, but all types can take advantage of this platform, where a whole host of different technologies are there that really serve as a springboard, or something that does some part of that DevOps work for you, right? So I think that it originally started by just taking the server and moving it from your office or on premises into a cloud where it's in its data center, and it's in a spot that's a little bit safer than what you could physically provide, maybe even with a better internet connection. But over time, it's evolved into something much more than that. And it's evolved into a collection of resources that you can tap into to make your development process go a little bit faster, to remove some complexities out of your systems. There's so much there in cloud computing. It's not really just servers in the cloud anymore. There's so much more there to it.
Exactly. You nailed it. Exactly. So, yeah, so let's, take an example or an analogy of car again. Uber, right? So, what is happening is you want a Mercedes car, which is $100,000, and then you pay insurance, you maintain it, and then because of COVID, you don't go out much, maybe once a week or once a month, but you're maintaining it. And sometime you see that, oh, its battery is down because I have not been running it, and there are a lot of maintenance overhead. What is the main aim of the car? To move you from place A to place B comfortably. So is there a way that you can adopt a model which is pay as you go? That is Uber. You just call a Uber would come, maybe they would charge you $100 an hour, but that's fine because your trip is maybe 5 hours, 10 hours. You pay once a month, $1,000, that's fine, which is less than the insurance or even the interest you pay on $100,000. So that is where how much you want. And then second thing is your Uber car, you don't have to manage, maintain, do nothing. And then you don't even have to worry about selling it, buying it, upgrading it, updating it. You could always ask for the latest model which is there, because now I buy Mercedes, after a couple of years it would be down market, it would be old. So I always want the best and the latest to drive and enjoy the luxury. So same model, Graham Weston from Rackspace, he was into real estate, and he predicted that 25 years ago that people are renting the houses and the apartments, and if somehow we can create a model wherein they can rent the computers and servers so that they don't have to own it, they don't have to manage it, but whatever they don't have to update their skill set and whatever are the things, but they can just enjoy the sweet fruit of just hosting their websites or their things on the cloud. So the very first cloud which came in the market was Rackspace. And that's how in this diagram we are trying to say that you can simply understand the iCloud concept with iPhone. So few years back, you had all your pictures on your phone. You lost the phone, you lost your memories. So either you take the backup, or if your phone memory is full, you're done. But now, since you have iCloud, so you put that thing somewhere in the cloud, but magically it's available on your phone. So your phone's capacity is unlimited. Like, you can take as many pictures and save them as much as you want. They will be available all the time for you. Now, where they get stored, can you go physically and touch? No, that's abstract thing. That's what we represented by cloud. You can see the cloud, but you cannot like literally touch. It's not ice. It's just, where it is, how is it. You even don't worry, you don't bother, you cannot touch, but you get what you want out of it. So cloud has started providing the storage services for pictures, and then it started providing, as Michael was saying, a lot of services. Database as a service on the cloud, so you don't have to secure your own data centers where you have electricity all the time. So there is one client of Rackspace. They created their own data center. Because of the summers and the overheating, as data increased, they put some more hardware, and then it burnt. Basically the entire building got burnt because of heating. So you have to think a lot, you have to plan a lot before, in terms of provisioning, getting the servers, getting the air conditioning, meeting the demand at that time, and it slows down the process, so it makes less agile, and it needs lot of investment upfront in terms of infrastructure. So with cloud, it's a shared model. Same infrastructure can be shared by different companies. They can use it at different or same point in time. A multi-tenancy architecture, it's safer than what you can keep. So there are a lot of benefits of the cloud computing. One of them is lower cost of ownership. You own it, and then it's like Uber. In $10 I can get a car to use. I don't have to upfront take a loan or nothing. It's always up. My car might be broke and I have to go for an important date, but Uber would be available. I just click the button, it would be at my door. Same with the cloud. They have a very high availability actually. There is disaster assistance. For example, I'm in San Antonio, there is hurricane, everything is gone. No worries. I have my data. They store, like, the cloud is big, it's global. And do not confuse it with the cloud in the sky. It has got nothing to do with that. I saw some of the videos where people were afraid that, hey, it's raining, maybe what would happen to our data which is in the cloud. So so nothing like that. It's just a terminology. So cloud means some part would be in Australia, Sydney. So this part of world might have hurricane, earthquakes, volcanoes, but the data is divided and shared among different geographical locations. So whenever there is any disaster in particular geography, data can be recovered or fetched from other locations. Then there are no IT maintenance cost, because you have virtual servers, or literally you have no servers. We will explore the concept of serverless. So it comes to the NoOps concept. Then you have offsite data storage as well, which is pretty much secure. You have productivity anywhere, and it's easy to upgrade. Technology is changing very fast. Like every 3 months, there is something new, which is less cost and more effect. But if you buy something, you are stuck with it. But if you are in cloud, you rent it for some time. The moment you don't like, you have something new, just switch, and switching over is easy. So that's where the benefits of cloud. Now let's understand what is more important in dev and ops. So dev is developer. Usually people think software engineers write code all the time, but that's not true. It's the other way around. I have an application. I am a software engineer, a programmer. So I would program it. For example, I have a program to calculate your age. So programming is done. But that service needs to be maintained, needs to be deployed, needs to be monitored. And we have to make sure that customers are not impacted if it is down. So programmer writes a program in a day and then he is done. Maybe he can go for vacation or he don't need work. But ops are the guys whose responsibility is to whatever the code developer gives, after testing, they would release it, they would deploy it in the physical boxes, if box needs upgrade, patching, there are a lot of tasks. We will see it in the next slide. So they have to operate and monitor. Sometime the server, due to hardware failure, is down 3 a.m. midnight, and customers are still waiting because it's daytime in India. They want to access, and now the ops, if they are here, they have to be up and fix it, like fix that all those problems. So that's not good. It's another example of Costco, wherein their code was good, but since there were some operational problems, so their ops team was not able to figure out much faster. And then God knows what was the problem, but it killed their entire, peak season. So that is why we don't want to manage any server. We don't want to see them. We don't want to touch them, so that we don't have the headache of managing, maintaining, or getting our ops on call midnight to fix anything. So, welcome to the world of serverless computing, which is the gift from cloud computing. So, cloud computing provides you the flexibility, low cost, pay as you go, elasticity. Elasticity means today you have one user, tomorrow morning. For example, just take the example of NASA. So, what would happen is NASA is going to send the man to the moon. Trump already said that, I think 2023. Michael, do you know what date they are planning for the man to moon mission? You're on mute.
Oh, sorry. So I don't know what date it is, but I know that it's coming soon. So I'm not 100% sure of the date, but I know that there's been one set, and I think, truthfully, I think Elon Musk will make it first.
I agree with you. Right. He launched his rocket, and then, for example, his website is getting 10,000 views per hour. The day he is going to send the man to the moon, Japan, Nepal, or whatever the remote countries, every citizen would like to watch that thing live. And then all the servers, if there are physical servers, they are going to get crashed. To avoid that, they would like to have an infrastructure which is auto healing, auto scale up, elastic, and serverless computing. So they don't have to bother. If the demand is high, it can adjust and adapt to even to get the trillions of the views on that video, or that incidents, or that event historic moment to cover up. So that is where we as a transport company are also trying to have seamless experience, serverless computing on latest technology of cloud, so that there is nothing stuck. Like we cannot send our truck from place A to place B because our servers are down. That's what the software cannot do things, or cannot dispatch, or cannot print this. So I have seen those things a lot of time, where software, instead of making them productive, becomes the bottleneck and the excuse also for drivers of being late and all.
For sure.
So serverless, if we can imagine that there are actually real servers, but what is happening is you have ops, a human has emotion, and human is managing all the things like your data patching, your security. If someone is hacking, so there will be some attempts, he's watching and monitoring. And then sometimes he's tired, so, and if he's tired, he can make mistake, and a small mistake, if reaches in production at a large scale, it can cost a lot of damage. And most of these things are pretty repetitive. So what the serverless computing does is they are doing the same thing, but it's abstract, it's automated, it is using AI/ML, which is artificial intelligence and machine learning. So in the background, instead of human doing, the machines are doing the deployments, they are handling the monitoring, so that your server is not getting hacked, it's super secure, it's always available, and it's meeting the demand in the time. If demand is low, it would scale down the servers, means it would turn off the server, so you don't have to pay whatever number of requests or whatever number of unit of time you're using a server, you will just pay that. When load increase, it would increase more servers. Instead of 5, it would make 20. Now taking the example of Costco, if there are more customers, more servers will spin up, so no user would feel the response time is sluggish and things like that. Taking example of Indian banks, when Prime Minister Narendra Modi demonetized, like he stopped the currency, few currency notes, and everyone was at the bank in the queue, and server were overloaded and down. So at that time, when bank need more of these server or compute power, the serverless computing, which means in an automated way, they would spin up more server to meet the demand. That is just the simple word, serverless, but actually there are servers, but those servers are managed in an automated way. So as a developer, you don't have to, or as a engineer or as a company, you don't have to worry about the infrastructure. You have to just focus on the code, the quality of your UI, how beautiful, pretty is it looking, the user friendliness of it, and rest all things are done. You even don't need a human to do it. So this is a brief discussion about DevOps versus NoOps. In the NoOps world, if you have a team of 20 people, 12 are in development and 8 are in the ops, and most of the time ops operation guys, they don't have work. They would be there just to monitor. If something is down, they can jump in and quickly fix it, because that's what they are there. But developers are coding all day long, trying to do a lot of things. So if you have no ops, you don't have to pay for those resources, since it's no ops, it's serverless. And those ops, you can utilize them to write code or to do some advanced level thing. So we are not saying that ops would lose jobs. Of course, whatever the serverless things are, they can leverage that, and for other automation stuff, they can use their time and energy in thinking of one level ahead for the company. And it's better for the user experiences also, because no emotions, no tiredness, no human touch, it's all automated. So when we see here, I know some of the ops guys in the audience might have got offended and would have plans to kill me after this presentation. So just to speak about them, I know my team members, ops guys, they work more than us, more than developers, because every other night there would be some or the other task. For example, in the data center, once they have the network set up, that's fine. Some router is down, some hub is overheated, they need to change some cables, the storage is running out, they have to upgrade the operating system, there are some security patches, and then PCI compliance want that all the latest version should be patched, because we are saving super secure information, PI data. So it cannot be on such server that is vulnerable. So they have to go through, and it's, like, if you will upgrade one thing, it would break 10 things. So you have to debug entire thing. So most of the times op are in the debug mode. Like, it's a finely balanced aircraft. If you put the weight, if you want to put a lot of weight in the tail basically, then the flight tendency would change, of course, right? So you have to balance it, and that's how they're patching and doing a lot of stuff all the time. Ops, I respect them. It's a lot more hard job. And like, once they do all that, they follow compliance, security, app servers, backups, monitoring, compute, network, everything, then it becomes available for developers to deploy their apps. But how about if we can use or leverage cloud computing platforms like GCP or Amazon or Azure? It would just remove all this headache, and then there are just apps which ops, DevOps, like everyone can just do code and deploy whenever they want in few clicks. So the deployment time is also faster. So that's the idea here. Now, serverless architecture also provides a lot of things with it. Not only the database, but API, you have the global, the file storage. You can easily monitor. There are CloudWatch services which can help you to track at each user level what he's doing, what are his intentions, what he did. Based on that, it can predict when the user would return, or if he's a hacker or things like that. Like, lot of things out of the box which comes. And the thing I would like to say about authentication service. So when you make a house, so Michael, this is a question to you. When you make a house, would you also like to make a lock, like homemade lock for your house? Or you would like to buy a properly tested, approved lock from the market to put on?
Yeah, so you know that almost everything that you put into a house that you build is something that someone else made, a third party made, produced, manufactured. Someone else probably tested it. The locks, the windows, the doors. They're tested for all sorts of things. Security is one of them, but there's so many things that they're tested for. So that's yeah, that's exactly what you want in cloud architecture too.
Exactly. So it's a jigsaw puzzle mix of lot of services. You tap and pay as you go. So that's the benefit of cloud computing. So now we will look at a small S3 bucket. It's a file storage serverless application by AWS. So you don't have to, for example, the organization. Look at transport. We have a lot of paper. We scan it, then we save it somewhere, and then we have the fear that if someone can steal it, or if our hard disk gets crashed, or if there are some virus in the network or the system, and a lot of things, right? And then how about when we have more data, we have to buy more storage, right? So all these things can be taken care by the simple S3 buckets, which is an Amazon service, which literally provides you unlimited storage with its versioning system, with like lot of benefits. If you would like to go serverless, you don't have to manage server, you don't have to upgrade or patch server, you just use it and enjoy it. So let's see the serverless storage demo real quick. So for that, what I'm going to do is, let me open up a browser.
So while you're doing that, let me speak to some of these things. Right, with what we're doing at Transport, we're using so many serverless technologies. I think, like many companies, we find ourselves striking a balance between some servers and some serverless components. We certainly have some things that we manage to build, like a Kubernetes cluster and things like that on top of. Of course, that could be serverless. It's not, but we use serverless functions in the form of Lambda functions to do some really neat things. We leverage database as a service, serverless databases via AWS RDS. So we're taking advantage of that. So it's great to just, all you have to do is think about the database. You don't have to think about the server that the database is on. So your database guys can just be database guys. Your application developers can focus on developing the application. And then we also use a lot of the S3 components or storage pieces, right? And S3, the security there is phenomenal. We take advantage of all of those security functions, and in fact, so much of what we're storing there is very secure. And we're using our application servers to deliver those via pre-signed URLs and things like that, so that we can store very sensitive things and sleep well at night without the worry of hackers, getting into it. Someone else takes care of that. And I would say that for us, and I'm sure that it's different for all teams, but for us, um, from a development to DevOps standpoint, or developer to DevOps standpoint, we've got right now, I would say, close to maybe a 12-to-1 or 14-to-1 ratio in developer to DevOps ratio, if we take that across our teams. And I would say that that's pretty phenomenal. He can handle things like the CI/CD pipeline and all of that, getting that set up. And then once that's set up, he can step back out of the way, and developers work their magic, and then the applications just appear and it works. And that's the magic and the beauty of serverless for us. It's phenomenal.
Yeah. So we have huge data, like we use historic data, like you cannot even imagine, like decades old. in S3 buckets. So we are going to quickly see the demo. So I'm going to create a bucket. So bucket is something wherein you can save your files basically. So I would say serverless demo, and then probably today's date, which would be July. I don't know. Let me just check. It's 28. It's
28.
yes, sir. It's July 28. So this is supposed to be unique, the bucket name. Once you have that, you can pick a region which is closer to wherever your work location is. So I'm just picking up Canada, and then you can save in different versions. For example, I am saving the copy of my license, and then once I have renewed my license, but still I would like to keep the old copy in case if it's needed for passport. So whatever data you are trying to save, you it's saved for once and forever, so you can always retrieve the older versions. That is what is called as the version capability in the bucket when you store it. Then you can block all public access. For this demo, to keep this thing simple, I would just allow all access, and then you can go ahead here, and then you can check all these settings, and then you can just create your bucket based on the permissions. uh, and let's do that. As simple as that, our bucket has been created and it's ready to use. So you don't have to think upfront how much data you want, how much space you need to buy or provision, or for how long and all that. It's there. And then they have Glacier and a lot of other services wherein they have AI implemented, artificial intelligence. So the data which is used often, it would be available in the caching mechanism. So the response time is faster. The data which is used less frequently could be, in the background. So when you need it, it's not occupying a space which is basically eating up the cost and also the resources. So what I'm going to do is I'm going to put the file for this presentation, just to give you a quick view of how quick this is, and we can provide the public access to read it. So let me go here. This is what I was talking about, the intelligent tiering, wherein you can put long-lived data. There are some PCI compliance to save 10-year-old data, and you need a low-cost storage. So you can put it in Glacier Deep Archive. Because if you would put in, frequently accessed data, it costs more. It costs more electricity. In Deep Glacier, it's super cheap. If you think that you need data once in a while, once in a year, or maybe less, better you put these things in the Glacier Deep services. So that's how there are a lot of options which are intended to make things pocket friendly for you. So now let me go here and then upload this in the cloud storage, which is Amazon S3, and it would show up in a bit. See, the progress has been made. It has uploaded our first data already. Now this would be available pretty much anywhere, and you can always have different options enabled in terms of security. But for this live demo purpose, I'm going to share the link in the chat, and then I would just like to let you guys try it out if you're able to see this. So let me put it in the chat to everyone. Michael, could you try and see if you have the access to this image which I just uploaded on the cloud? So I am in US right now, and I uploaded it in the Canadian region. But what I want is someone from India or someone from Austin should be able to get this data or read this data instantly.
I got it.
Oh, wonderful. So this is how simple the serverless thing, because now I don't even worry about crashing the file server. Let it crash, it will be recovered. It's redundant, it has multiple copies, and that is all the benefits. Now, moving to the next thing is this the time of election, and that's what I just try to create a small application which is based on the serverless architecture, which would help people to e-vote. So what we have leveraged is one is Amazon DB, which would collect all the votes, whatever you give. So you don't usually for database you would provision the server, then you would install the software, then you would have lot of securities, then you would combine that database with the app, and there is a lot of drama things planning. Even after that, there are a lot of chances of hacking if you even lose one thing. So let us leave it on the experts. Amazon guys have done all those security thing. They keep on auditing, and we use. So I stored about 18.5 million data. And problem with the like if you do server on your own is as data increases, the database server slows down, and that's where the problem comes. And that problem has been solved by the serverless data proprietary from Amazon DynamoDB. So I still get a sub-second response between 18.5 million records, what I have stored. And this December, I am planning to put around 1 billion records. But my SLA is whatever password. So I implemented a password blacklist feature. So whatever user is typing, I need to make sure that it's not one of the compromised software in those 1 billion password. And to do that job, this guy is great. Amazon DynamoDB. I'll show you that. Then, as Michael was saying, we are using a lot of Lambda functions, AWS. So typically, when you write code, it's just the function which is doing. For example, you're adding two numbers. So you have the function parameters of 2 plus 2 returned would be 4. But to do that, you will have to have a server, you will have the code, if you are doing it in Java, you have to compile it, you have to create the var, you have to run the build, then you have to give it to ops would deploy it, then they will, once the deployment happens, they'll make sure everything is fine, networking and all that. After that, you can run it. But here in serverless case, you can directly type on the browser. Basically, I'm going to show you soon. And then that's it. Like no deployment, longer procedure and nothing. It's quick response, it's quick agile. And 1 million requests on a Lambda function are free per month. And literally that is true. I have been using that. And 1 million hits is a large number. So practically you can run most of your mid to small scale application literally for free, unless you are not sending man to the moon and using using that kind of free tier. And then we will be using API gateway, which would apply the exposure of your endpoints or the code which you have written in AWS to the external world, which would essentially be our microservice. And then it can be plugged into any web application or any mobile phone. So that it can be consumed. So let's look at the application on EC2. So let's go to the AWS first. Then we would go here, and first we would start with the API gateway. And before I show you this, let me open up my Postman. So what we are going to do is we'll follow a KISS principle. So don't worry, it's Corona time. I'm not going to kiss anybody, but KISS is keep it simple, silly. So this is just a simple app, which is a REST endpoint, and this REST endpoint is eVote, which would take two parameters. I did not make it a get call; it's a post call because we are posting data. So you have a over voter ID, which would be something unique, which is essentially here my phone number and whomsoever you want to vote for. It could be Donald Trump, Narendra Modi, Biden, or maybe Michael Steele. So now I changed my mind. So let me change my vote. Sorry, Kumo. So that's the vote goes to my best friend. So as soon as I click send, I got the response status code is 200. Thanks for exercising your voting right. Now, this is a simple REST API, but what's happening behind the scene is we have the API gateway here, and inside that you can generate entire CRUD operation, get, post, put, whatever you want. We just are doing, it's a one-way thing. You would vote, right? So it's a post call. Once you do that, and then this would be invoking another small function. So it's modular. It's small functions tied together in a very strong network in security, so that it cannot be broken apart. But if there are larger responses, this API gateway expands. Right now we are making one request per minute, but if there are 1 million requests per minute, it would create multiple copies of API gateway, which would start handling all those requests, so that you don't get from the front end no server down. And then it takes it back to the next layer, which would be our middleware, or the backend basically, which is a Lambda function. So this is just a simple Lambda function which is grabbing your voting. We are using the DynamoDB table using the Boto, and DynamoDB table, once you save the record, it's coming back, and that's what it is responding. You can do the unit testing of the AWS Lambda here just by clicking the test. You can see the logs. If there are any errors, you can catch it here. So it's pretty neat way. You don't have to run end to end each time. You can test your API gateway separately, this piece separately, DB separately. You can connect, you can change versions, you can change deployments as well. Here you can see you could always make the production, and there are a lot of stages also. So that I'll cover in another demonstration, a detailed demonstration on how to leverage, because it's a topic in itself. But yes, in short, it makes managing the different environments and different versions of the application very easy, super easy. Sometimes it's annoying, you have some customer using your version 1 and you want to upgrade it, but you cannot upgrade because you will break the contract. So in this case, if you have serverless, because in older case you have one server, so either you will have the old version or the new, but you cannot keep both. In serverless, you don't have server, you can make both application APIs available. Then what would happen is, once that customer in his sweet time period starts finishing it, then you can always stop the older version. So you can manage as many versions as you want for the application. Now, third thing, where when we talked about the DynamoDB, how it is, connected, you can always have the concurrency limit, like 1,000 users. Why is that? Because when someone is trying to do a dictionary attack, he might try to hit 10,000 or a million time, and you don't want that. So any number you can provide any concurrency, which should be good enough, so that a hacker, you are not supporting the hacker to use your scaling up thing against you and hack you faster. Fine. So that is why you have a pretty much good control on that. Now let's move to the database part. So this is how the Amazon services, pretty much all cloud computing provides you the UI. From there, you can type the service name where you want to go. In this case, we have DynamoDB. So we'll go there and we can look at the tables. So this is what we have here in the tables and the items. So I have this item over here. Let me delete this. Sorry, Michael, this was my old vote actually. So,
Yeah, I don't understand what happened.
so what happened is the voter ID is unique, and I already had that data basically. So it did not overwrite it, because
Wait,
once
so
you
you're
vote,
saying voters with e-voting can only vote once?
yeah,
Sounds like what we need.
that is what we need, right? So now let's see, we got 200, and if everything is fine, we see my best friend's name, and yay, here it is.
We got it.
It's subsect.
Thankfully, it'll be the only vote that I get, so no chance I'll have to be president.
And it maybe it's like who is voting you or who's picking you. That's more important, right?
That's right.
So if I am picking you, maybe there are several people, but still my wishes might come true. So, so yeah, so guys, this is pretty much it we wanted to cover in today's session. And then I would like to thank you. And Michael would do the conclusion for this serverless cloud computing conversation. Yeah, Michael, please.
Yeah, so I would say a couple of things. So first of all, the presentation has been fantastic, and I think it's a really great overview and look at serverless computing and the tools available and a high-level overview of how they work. But I would add to it some things that people should come back to hear more about from you, right? Which is that one of the neatest things about serverless computing and cloud computing is this concept of infrastructure as code, right? So you can now version all of your servers, if you will, in code, and you can save all of that in your version control system in your GitHub, and you can include in your application code. You can include all of the server or serverless components that you need. So all the cloud components that you need can be written into its own infrastructure code, and literally can be launched with a very simple command. Can launch your code, can deploy your application, and next thing you know, a very complex, multi-dimensional set of microservices and applications are all up and running with many interdependencies. It's all happening, and it's really simple. So that's the follow-up topic for you, and no doubt, it serverless is it's not just the future; it's the now. It's happening now. It's the only way to be doing it. From a business standpoint, I will tell you that we've had so many conversations over the years throughout various businesses where we face IT questions or questions, even business questions. Why do we do something the way that we do it? And over, you'll hear folks in an organization give you an answer. Well, that's just the way we've always done it. And maybe we've done it that way for 30 years. Maybe we've done it that way for 20 years. Maybe we've done it that way for a year. I always want to know, is there a better way to do it? And by far, serverless is a better way to do so much of what we already do in computing. So if it's not adopted now in your organization or in your practices, it should be. So be serverless.
Yeah, that's right. So as Michael said, we would be covering a few things in some of our next topics, which would be infrastructure as a code. And there are several options of doing that. One way is to do it through Terraform, and I would love to present something on Terraform soon, Michael. And then CloudFormation is another way which provides you to write the stack, which is specific to AWS, of course. So you can write your full stack of your application in terms of a CloudFormation template, which is simple JSON based on Groovy based syntax. And just you run it, and your entire infrastructure, including your static or elastic IPs, network policies, connectivity, your CIDR block and ranges, your protected network, everything can spin up and clone itself pretty rapidly. Apart from it, last time we did a demo on Fargate, which is a type of infrastructure as a code wherein you have the containers, and container you just have the commands written down in the Docker file, which would be in a serverless way, can keep running, can keep healing, can keep cloning themselves based on the thresholds or the need or the availability. Whenever it's needed to be available, it would scale it up or down to save cost. So that is pretty much it, and I hope you guys enjoyed. So please leave us a comment if you have any questions, or reach out to our LinkedIn page of with transport. And interact. Let's talk, and we would love to go with coffee for a coffee with you after Corona, not now.
Absolutely.
Maybe Michael, you can go and like have take them to some mountains if someone wants some spiritual and technical mixed of talk in some of the beautiful nature and some scene for more inspiration.
I think we could both do that, but we can have virtual coffee anytime with anyone.
Yeah, of course. Sure.
Yeah,
Okay, guys. Yeah. Bye.
super. Bye, everyone.